differentiate between surfaces like these shown here. The surface on the left and the surface on the right, identical RA, but they have very markedly different parameters such as slope, RMS surface slope, the developed surface area, the bearing index, and the skewness. And these types of parameters can allow for a differentiation and a direct correlation to photovoltaic efficiency. So within the Contour Profiler series and the optical software Vision 64 version 5.3, which was recently released, we have a solar analysis which allows for the immediate computation and multiple region analysis of solar pyramid peaks. It lets you do automated analysis of RMS slopes, the surface bearing. It allows for a nice, easy, and fast view of a large field of view. Well, you can see in the lower right, you can see some potential saw damage and these types of things for revealing regional variations. And it does this all at a very high rate of speed. The measurements on each location are just a few seconds. And then you can set up to monitor a finished product, for example, at multiple locations. You can set up to monitor the substrates directly after sawing, etc. And the main takeaway here is that we're trying to develop this to directly suit the software to provide analyses suited for process control. So this slide, what I want to share here is that the various texturing processes require various analyses in order to correlate to direct efficiency. The pyramidal structures that are common for alkaline etching, you can see down at the bottom or over to the top left corner. Those structures are best suited for analysis with the RMS slopes, the SBI, and the SDR parameters. And the SSK parameter, or skewness, will help to correlate directly to efficiency for acidic etched surfaces. So the main takeaway here is that there are parameters that can correlate directly to end product efficiency across a variety of surface preparation and texturing. Summary, and then we're going to open up for questions. I've tried to show that there's a competitive market with various technologies and solar efficiencies nearing theoretical limits. So quality process control becomes more and more important as the need to increase your yield and bottom line increases and will enable you to compete better as efficiencies improve further from where they are towards the end resultant limit. I wanted to show that we have stylus and optical instruments here available that provide excellent complementary metrology, which can be used throughout these types of processes in order to enable you to get that better and more accurate final control over the yield of the end products. And the metrology is effective across a wide range and many surfaces of a variety of applications for the photovoltaics industry. And we've tailored our software to provide analyses that are specific for the solar industry. I talked specifically about the white light interference method for making a 3D microscopic measurement and discussed why we don't position the Pico Contour, our VCM, for this type of an application. And I also wanted to add that we do have multiple fielded installations providing this type of fast, accurate process control. So I've got a slide up now, and at this point I'd like to just remind you again that we have an exit survey that I would really appreciate if you take the 5 questions and answer them. This is a question slide, and please, if you have any questions, you can email me. You can check these links for product information. You can write for sales information, and you can also look at the webinar series and archives that we have. I would appreciate very much that you take the time to answer the exit survey so we can improve this webinar series as well. And at this point, I'd like to open up for some questions. So I'm going to go ahead and paraphrase one of the first questions we have here is, what are the typical fields of view that would be required to correlate with performance? And the honest answer is that we have tried to make correlations with smaller and smaller fields of view to up at, a 50 micron by 50 micron type box, but the results were awful, and that would correspond to something like a 50x to 100x magnification. You could go 100x magnification, would be something smaller than that depending on the numerical aperture. But we've done best with fields of view that were approaching a millimeter on a side. In other words, at a much lower magnification. We typically use a 5x magnification to make these types of measurements on the optical tool. And the difficulty there for a focal tool, and the reason we don't present this as an option, even though we offer the confocal tool, is that we feel the time and the time needed to get a stitching of accurate vertical data from the confocal for such a big field of view would be prohibitive. And at 5x, the magnification of 5x, the confocal vertical resolution just isn't there to give the good differentiation of the surface information. Okay, so we have a different comment which is relating to that about accurate metrology for assuming the same field of view or having comparing confocal with white light. The confocal tool, there are some advantages in terms of the numerical aperture. It can see where measurement will make on a very steeply sloped or very highly reflective surface. It may do better in terms of getting information further down that steeply sloped surface. As far as the accuracy of the techniques, assuming adequate fields of view, the question is being asked, for the same fields of view, the vertical resolution of the white light instrument will win at the lower magnifications, obviously, because I think it's hundreds of nanometers for the confocal tool versus just a handful of nanometers for scanning measurements on the white light instrument. So there are a few applications where the confocal will provide more data or more information. At the higher magnifications, the resolutions are comparable for a smaller field of view. But at the lower magnifications and larger fields of view, the white light instruments are clear in terms of accurate metrology. Another question we have here is it possible to have automated metrology on all the optical tools that are offered by Bruker? And the answer is no. There are some tabletop more research, development, and lower cost of entry point systems that we offer that have only manual stages that aren't able to handle automated type runs. That being said, those tools can still support the K-series, Contour K-series products can still support these types of analyses we talked about here today and showed for the solar analysis. So that instrument is used as a process development So another question is, what was the, excuse me. What is the significance of SSK? So, what I hope that you would take away from these S parameters, the S parameters were developed as a three-dimensional complement to what was traditional in a two-dimensional way in stylus profiling. And skewness can be measured along a two-dimensional trace as well as in a three-dimensional way. And what it does is it enables you to know this height waviness, I guess, is what I would think of it as. It's a unitless parameter that you can look at how much of a surface is above or below, and what I guess that would be kurtosis. I don't want to say that. So, but the significance of it in terms of the analysis that we presented here today is that it enables the correlation to actual product efficiency for acidic edge surfaces, whereas the RMS slope type information was what was used to do that correlation for the alkaline edge type surfaces. Well, again, thank you for the questions, and I want to another So here's a question regarding the performance correlation for evaporative SIGs type fabrication process, and that's something that I would have to check to be sure of my answer. My feeling is that it may be able to disclose type information and have to do with kurtosis or skewness as well, because it's one of the thin film type processes, but I wouldn't go that without checking in the experimentation done in the development here within our group to be sure that we've actually done that type of work before I would answer. The beauty of the S parameters is that this type of application is when you have decided upon a process and know of processing steps that provide the type of output and material quality that you like, then a careful study can be done and very easily show the correlation that you need for the metric that you have. And this is something that was done at least for those examples that I showed during the presentation with the monocrystalline silicon, the alkaline edge, and also the acid edge type surface that we showed for skewness, and then the RMS slope type parameters and bearing parameters or developed surface area ratio for correlating to the end product efficiency. Well, I hope that everyone enjoyed the presentation and can see the benefits to having good process metrology tools. The goal is to be able to help you as manufacturers develop a method that will achieve the highest efficiency, highest yield, and lowest cost. And we've had lots of experience doing that with other manufacturers, and it would be great for us to be able to provide solutions for you. So to that end, I'd like to remind you one last time, if you could please fill out the exit survey. It's 5 questions, I believe, 30 seconds worth of time. And also, importantly, if you've got questions at all for me that I can answer in a more thorough way, please send email to me, and it's displayed there on the question sheet at the top. I'd be happy to either answer the question outright if I know it, or track down the answer for you if I do not. And I want to thank you very much for your time and for attending this webinar this morning. And I appreciate it. Have a great day.
Hello everyone, thanks for joining us here today for Bruker's webinar on improving yield with 3D static dynamic bus characterization. Just a couple points before we begin. Everyone will be muted for the duration. Alright, is this working? Can you hear me now, sir? Hello?
でもそうやろ。でもさ、ちゃんとしてるよな。
Hello?